Hi, everybody. This week we're going to work with simplifying, multiplying, dividing, adding, and subtracting rational expressions. So, what's a rational expression? Well, a rational expression is just a fractional expression involving numbers, letters, usually some exponents, and even some terms that can be factored. So for example, if I take negative 5x to the third y over 15x y to the third, the first thing I should do is a prime factorization. I can rewrite negative 5 as negative 1 times 5. I'm going to break apart the x's, so 3x's into y in the numerator. In the denominator, I break apart the 15, 5 times 3, break apart the x, and then the y to the third. Now, notice that the 5's cancel, an x cancels, and a y cancels. And that's how I get my final answer, or my simplified answer, of negative 1 x squared over 3y to the second. Let's try another example. In this example, you notice that the numerator is a binomial because there are two terms, and something that's common to those two terms is the 3 and a c. I can factor out a 3c. Here I'm just factoring out the greatest common factor. Double check it. 3c times 2c is 6c squared, and then 3c times 3 is 9c. So if I distribute the 3c back in, yep, my numerator checks out. So after I've factored out that common factor of 3c in the numerator, the 3's cancel, the c's cancel, and I'm left with 2c plus 3. Now, if you've got a binomial or a trinomial or any sort of polynomial in either the numerator or the denominator, you can't just cancel certain chunks. You have to factor out something because you can only cancel things that are being multiplied together. Example 3, or C. So here we have a trinomial in the numerator and a trinomial in the denominator. I had 3's on my brain because I have 3 terms in the numerator, three terms in the denominator. Now these are all trinomials that we would consider to be plain trinomials because they don't have a leading coefficient other than 1. Notice how I used a big X to quickly factor the numerator. What two numbers multiply to 16 but add up to 8? 4 and 4. Notice the factored form to the right of that. In the denominator, I also used the big X. I found two numbers that multiply to negative 24 but add up to negative 2, negative 6 and 4. So once I had those two, numerator and the denominator factored, I had the two trinomials factored, then I could cancel out the x plus 4's because that was a common factor in the numerator and the denominator. So just like I wouldn't have just canceled 6c squared and 3c in part B, I factored out the 3c before I canceled. I had to do the same thing here for letter C. I had to factor first. So I can't just go and lob off the x squared or reduce 8x and negative 2x. No, no, no. You must factor. All right, so if you have a polynomial, remember to take out the GCF. All right, last example, 2x over 4x squared minus 2x. So I know what you're itching to do. I know what you want to do. You want to just cross out those two x's. Doesn't that make sense? No! You have to factor a polynomial before you can factor. So in the denominator, look at what I did here in the bottom. Yes, darling, factor out the 2x from the denominator. You're left with 2x minus 1 in the denominator. So cancel out those common factors, 2x and 2x. And yes, darling, 1 over 2x minus 1. So you're probably thinking, do I have to have the parentheses around that 2x minus 1? Well, no, you don't, but just leave them there. They're free, use lots. And you'll even notice that in example C, I kept my parentheses. So remember that you can only cancel out a chunk that's wrapped in parentheses. So if that helps you to remember whoa, when not to cancel and when to cancel, go for it. All right, so that's all I have to say about that. Please look in the Google Classroom. I have a worksheet for you to do. Just open up the worksheet, do the problems on a separate piece of paper, and then I believe I'm going to have you upload your answers to a Google Doc. Thanks. I hope you're having a great Tuesday.